Hello everyone, welcome to my dynamics class. In the first session, I review some basic mathematics that we are going to use a lot during this semester, and also I try to give you a big picture of what we are going to do during this course. So in statics, which probably we had it in the previous semester, you learned if we have a body or maybe a system of multiple bodies with bunch of forces and moments on it, like for example F1, F2, F3, and maybe more forces and maybe a bunch of moments like M1, M2, then in statics, you learned that sum of all of these forces in vector form is going to be equal to 0. If you consider all the forces that you have in your system, summation of them must be equal to 0. And usually you split this equation and write it in different directions. Sum of the forces in the x direction is equal to 0. Sum of the forces in the y direction is equal to 0. Or sum of the forces in the z direction is equal to 0. Or in general, sum of the forces in any direction is equal to 0. It doesn't matter what direction. You can just pick a random direction, find the components of the forces in that direction, add them together, it must be equal to 0. And same thing for the moments. Sum of the moments must be equal to 0. Again, you can split this equation and you can write this equation in different directions too. Some of the moments in x direction, some of the moments in y, or some of the moments in z, or in general, some of the moments in any direction is equal to 0. These equations are for static case. So when your system is in a stationary condition or it is moving with a constant velocity, we call it a static condition, right? Equilibrium. So the only important equations that you learned in statics are these two equations, which are not really independent from each other. This is the equation, which is Newton's first law. In dynamics, during the whole of this semester, we are going to learn if you have a mass or maybe a system of mass with a bunch of forces and moments on it, then sum of the moments, sum of the forces is going to be equal to mass times acceleration. An acceleration of the centroid. So if we have this, for example, rigid body, and let's say the centroid of it is here, and this centroid is going to have an acceleration which is not equal to 0, like a static condition, right? So in general, it is not equal to 0. It can be anything. Some of the forces is going to be in the direction of that acceleration, and more accurately, some of the forces is equal to mass times acceleration of the centroid. And again, you can write this equation in different directions, like sum of the forces in the x direction is going to be equal to mass times acceleration in the x direction. Sum of the forces in the y direction is equal to mass times acceleration of the centroid in the y direction, etc. Sum of the forces in any direction is equal to mass times acceleration in that direction. And similarly, we have sum of the moments, which is not equal to 0 here, like a static condition. And also there is a big difference between sum of the moments equation in dynamics and statics. In statics, we had sum of the moments about any point, any arbitrary point is equal to 0. We can take the moment about, for example, this point of all the forces and moments, and that's going to be equal to 0. Sum of the moments about any other point is equal to 0 too. But in dynamics, we are going to see it in chapter 6. Sum of the moments only about the centroid is equal to a constant number, which is going to be mass moment of inertia, which we are going to talk about it in chapter 6, times angular acceleration. So if our rigid body rotates with some velocity like omega and some angular acceleration, which we are going to talk about them later in chapter 5, then sum of the moments about the centroid is going to be the mass moment of inertia about the centroid times angular acceleration. And this equation is not going to be valid for taking moment about random points. If you want to take the moment about random points, we're going to have a complicated equation for it. So, in summary, these are the equations that we are going to learn in this class, comparing to these equations that you learned in statics, right? We don't really have much theory here, but we have a lot of small points that we are going to learn one by one during this semester and use them to solve different problems. In dynamics, sometimes we talk about just kinematics. So you're going to see this in all through this course. Sometimes we talk about kinematics, which means we are going to talk about the movement of our masses without considering the forces. What's the meaning of that? We are going to talk about, for example, of the velocity of a rigid body or maybe a point mass. If we talk about the velocity or acceleration without talking about the force, that is called kinematics. We are analyzing the kinematics of the body without knowing anything about the force. For example, if I know acceleration of this mass is equal to 1, for example, and want to know how the velocity of it is changing from time is equal to 0 to time is equal to 5, I don't need to know anything about the force. Using the acceleration, I'm going to be able to find the velocity of this mass over these 5 seconds, for example. So these are called kinematic analysis. But later, we are going to talk about the kinetics as well. So in kinetics, or some people just call it dynamics, we are going to learn about the relationship between the force and kinematics, like acceleration and velocities, which is nothing but Newton's second law. Sum of the forces is equal to mass times acceleration. For example, we are going to learn if we want this body to have some specific acceleration in some specific direction, then what forces we need to apply to this, right? So we are going to deal with forces and accelerations and velocities. So these are two categories of the materials that we are going to have during this class. Okay, so we are going to talk about them quite a lot. In chapter 2, we talk about kinematics of point masses, just particles. So first of all, we are going to talk about only particles. So what is the relationship between velocity and acceleration for a particle? That's called kinematics. Then in chapter 3, we are going to talk about dynamics or kinetics of particles. If you have a bunch of particles which are moving with different accelerations, then what is the relationship between those accelerations and forces? We are going to study it in chapter 3. We don't have chapter 4. In chapter 4, we talk about a bunch of particles together, the dynamics of it, which is going to lead to a bunch of equations that we need to know in chapter 5 and 6, which I'm going to give you those equations. In chapter 5, we talk about kinematics of a rigid body. So if we have a rigid body, a mass which has some dimension, it's not just a point, then what is the kinematics of it? What is the relationship between velocity and acceleration of different points of it? So we talk about that in chapter 5. In chapter 6, we are going to talk about dynamics or kinetics of rigid bodies. If I have a rigid body with a bunch of forces on it, how it's going to move, right? So this is just a summary of what we are going to learn in this course. So before diving into those materials, I'm going to talk about some introductions, mostly mathematical introductions that you need to know throughout the semester. Then we move to chapter 2 to talk about kinematics of particles. So first of all, units. So we are going to have different quantities, like what you had in other courses in your physics or statics. Quantities like mass, which we show it with m, length, which we usually show it with L, time, which mostly we show it with T, and also force, which most of the time we show it with F. So these are the quantities that we use, right? And we use two different standards to show them. We use standard units, or we use US units. So for the mass in the standard units, we use kilogram for mass, and we use meter for length, and we use second for time, and also we use Newton for force. So these are the units that we usually use in standard format. And you need to know that force is not anything independent from mass, time, and length, right? Based on Newton equation, force is equal to mass times acceleration, and acceleration is meter per second squared. So Newton is not anything independent from these two. So these three are basic quantities, and the force is something dependent to these two, to the three. For US units, for mass, which is quite unusual, but we use slug if you want to show the mass of something. And for length, we use foot. And we use second for time, which is exactly the same thing. But whenever we are using US unit, you need to use SEC. So this is a convention. If you are using US units, for seconds, just write SEC for seconds, right? And also for force, we use pound. In US units, we say these three are independent units or independent quantities, and we consider mass as a function of these three. And because of that, we rarely use the slug, right? So very basic phenomenon. And also we have some basic math, usually trigonometry, that we need to know. We need to know what is the definition of sine, cosine, tangent, cotangent, etc. And also some specific equations that we use a lot to solve the problems that you need to know from trigonometry. If I have two angles like alpha and beta, then sine of alpha plus or minus beta is equal to sine of alpha times cosine of beta. If you have a plus here, plus. If you have a minus here, minus here, then cosine of alpha times sine of beta. And also we have similar thing for cosine equation. Cosine of alpha plus or minus beta is equal to cosine of alpha, cosine of beta. If you have plus, you need to use minus here. If you have minus, you need to use plus here. Times sine of alpha times sine of beta. So these are two very important equations. And also the basic things which you probably know. Sine squared of any angle like alpha plus cosine squared of that angle is equal to 1. Again, very important equation. And also if you divide both sides of these two, like for example cosine of alpha, cosine squared of alpha, we are going to have tangent squared of any angle like alpha is going to be equal to 1 divided by cosine squared of alpha minus 1. And we use this equation a lot too in some problems. Okay. And other basic math, we have law of sines. If we have a triangle, any arbitrary triangle, with the angles of A, B, C, and sides of small a, small b, small c. So this angle is A, this angle is B, and this angle is C. And the side in front of A is small a, the length. Same thing for the others. Probably you know this. Sine of each angle, like for example A, if you divide it to the length of the front side, it's going to be the same for all of them. So sine of A divided by A is equal to sine of B divided by B is equal to sine of C divided by length C. And also we have another one, law of cosines. We have this relationship between the sides of a triangle. For example, you can write a squared is equal to b squared plus c squared minus 2 times b times c times the angle between them, which is a, times cosine of the angle between them, which is cosine of a. And you can do the same thing for the other side. So for example, you can write b squared is equal to a squared plus c squared minus 2 times a times c times cosine of b, right? So you can have different versions of this equation. And the other introduction, just quickly, we have two types of quantities. We have scalars and also we have vectors. So scalars like mass, maybe, length, speed, etc. These quantities have a value, but they don't have any direction. For example, if mass of something is 1 kilogram, it is 1 kilogram. No one is going to ask in what direction. Same thing for length, same thing for speed. So if we say speed of something is 1 meter per second, that's the speed of it, right? But the velocity is a vector. If I say velocity of something in 1 meter per second, you can ask in what direction. So we need to specify the direction too. So vectors like, for example, velocity, acceleration, force, they have value and also they have direction too, right? We sure are quite familiar with these topics. And a few important things about vectors, just the basic math of them. If I have two vectors, like for example vector A and vector B, if you want to add them together, there are different ways to do it. We should learn from in statics, but probably the easiest way and also more systematic way is adding the x component of these two together. That's going to be the I direction, and the y components of them together, they go together. You need to add them together. That's going to be the j component of it, right? So it's going to be something times I plus something times j. And this something is the x component of this one plus the x component of the other one. And this one, a y component of A plus y component of B, right? And if you remember, we had dot product as well. The dot product of the two vectors is going to be the magnitude of them, like A times B. A means the magnitude of vector A. B means magnitude of vector B. I don't have any vector sign for them. Times the sine of the angle between them. The cosine of the angle between them. So if the angle between them is theta, then I'm going to have cosine of theta here. And also the other way to calculate them, if you know what is the x and y component of these two vectors, you need to multiply the x component together, the y components together, then add them together. That's another way to find the dot product of two vectors. And similarly, we have cross product, which was quite useful in statics, and it's going to be very useful in dynamics too. If you cross product two vectors, the result is not going to be a scalar like the previous one. We are going to have a vector. And this new vector is going to be perpendicular to A and B. So if A and B are making a plane, the product of them is going to be perpendicular to that plane. So A cross B is going to be a vector which is perpendicular to A and also perpendicular to B, to both of them. And the value of it, if I call this C, the magnitude of the C is going to be the magnitude of A times magnitude of B times the sine of the angle between them, sine of theta. Okay? And there is another way to find this vector. So if I show A with the components of it, like AX, AY, AZ, this means component of X in the A in the X direction, component of A in the Y direction, and also Z direction. And if I do the same thing for B, BX, BY, BZ, then this is another way to calculate the cross product. A cross B is going to be equal to determinant of this matrix. The first row is going to be IJK. The second row is going to be components of A, the first vector, AX, AY, AZ. And the last one is going to be the components of the last vector, BX, BY, BZ. So if you calculate this determinant, the result is going to be the cross product of these two vectors. And also another way to calculate the cross product is using this diagram, if you remember. So if you show IJK on a circle and consider the clockwise direction as your positive direction, then I cross J is K based on this diagram. J cross K is I. K cross I is J. If you go in the opposite direction, then you're going to have a negative thing. For example, I cross K is going to be negative J. K cross J is going to be negative I. And same wise, J cross I is going to be negative K. So let me write a few of them. I cross J is K. J cross K is I. And if you inverse the order, it's going to be negative. Like for example, J cross I is negative K. Or K cross J is negative I. And also cross product of two parallel vector is equal to 0, right? We have that all the time. Or I can show it this way. I cross I is equal to J cross J is equal to K cross K, and all of them are equal to 0. For dot product, the dot product of two perpendicular vectors is equal to 0. For example, I cross I dot J, or J dot K, or K dot I, all of them are equal to 0 because they are perpendicular to each other. Another important point, just random thing, the order in cross product is important. A cross B is not equal to B cross A, right? They are opposite of each other. A cross B is equal to negative B cross A. But in dot product, the order doesn't matter. A dot B is equal to B dot A, okay? So these are just random important points just introduction. In the next video, I'm going to talk a little bit about vectors and then gravitational forces. And these are going to be chapter 1 of your book. Then we move to chapter 2, which is an important section of your book.